All right, hello. Okay, we are nearing the end of this packet here. So we are talking about inverse functions today. We want to be able to identify one-to-one functions and then determine the inverse algebraically. So first of all, we want to talk about inverses. We use inverses all the time. So when we're solving equations, if we have something like x minus 3 equals 12, we use the inverse operations to solve. So the inverse thing here, instead of minus 3, would be plus 3 on both sides. We use the inverse operations all the time to solve. We can do the same thing with functions. So we can create an inverse function, which basically is exactly the opposite of the function we started with. So inverse relations. What is the inverse relation? It is a relation that reverses another relation, which is kind of a weird statement. The notation for an inverse function, or inverse relation, I guess, inverse relation R, is r to the negative 1. And that negative 1 power in this case means the word inverse, okay? So we would say R inverse. So it's not to be confused with something like 2 to the negative 1. This is not function notation. This is actual exponent notation. All right, I got a number to the negative 1 power. That means it's a reciprocal, 1 over 2, okay? But this is function notation, so it has a letter to the negative 1. So that means that it's R inverse, okay? So to get an inverse relation, all we have to do is swap the x and y. So if my relation here is 0, negative 7, what's the inverse? So swap the x and y. That's all we have to do is trade places. Negative 7, 0, yep. So an inverse just swaps your x's and y's. So negative 1, 2, the inverse point would be 2, negative 1. And negative 4, negative 2's inverse would be negative 2, negative 4. And 6, 3 becomes 3, 6. So an inverse relation, all it does is swap the x and y. Now, there it goes. Okay. Graphically, it does the same thing. And I want to point this out because I think some of the problems on Delta Math are going to be, hey, graph the inverse. So I want to graph. Here's a function. My function, this function is going to go through 0, 1, and this point here, which I'm going to call, 3, 5 maybe. We're going to pretend, okay? So here is my function f. And what I want to do then is graph the inverse. So if I know it goes through 0, 1, and 3, 5, then I also know some ordered pairs on my inverse. So what would my inverse point be? 1, 0. So right here would be the point 1, 0. And 3, 5 is going to become 5, 3, which is maybe like here. And it becomes 5, 3. And so then it looks something like this, like that. And this is my f inverse, my inverse function, okay? So if we are given a graph, we can find the inverse by simply looking at ordered pairs and swapping them, okay? Now, to actually be able to have an inverse function, our function has to be one-to-one. So we have a function has a 1, I'm not going to write it out. I'm going to abbreviate here, 1, 2, 1. That's what that means, 1-to-1. A 1-to-1 relationship relationship. One-to-one relationship if the relation and its inverse are functions. And in order to be a function, it must pass the vertical line test. So what we have here is I can graph a relation like I did here. I graphed this sort of function f, and then I sketched its inverse by simply swapping the ordered pairs. Now, when I look at these two functions, my pink and my blue, are they both functions? Yes, they are. They both pass the vertical line test. And because of that, they are one-to-one functions, all right? So what does it mean? How do we know? The easiest way to know if they are one-to-one is to use the horizontal line test. So the vertical line test is used to determine whether a relation is a function. And then the horizontal line test can be used to determine whether the inverse is a function. So we actually can look at a graph pretty easily and determine if the inverse will be a function by simply asking, hey, does it pass the horizontal and vertical line test? So the relation and its inverse must be a function in order to be a one-to-one function. That's really weird, but here's what we're going to do. We want to determine whether the relations are one-to-one functions. A one-to-one function just means, hey, does it pass the vertical line test and the horizontal line test? Horizontal. Oh, I could just write HLT. That would be better. All right, HLT. All right, there we go. So in order to be one-to-one, it's got to pass both tests. So, number one, does it pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. Yes, so then the inverse, then it is one-to-one. Yes, it's one-to-one. No, it is not. Why is it not? Yeah, fails horizontal line test. Because if I draw a horizontal line, it's intersecting in many, many places there. That fails. It can only intersect one time. Number three, yes, it passes both the vertical line test and the horizontal line test. Number four is yes, it passes both the vertical and horizontal line test. Five is no. It definitely fails the horizontal line test. Yeah. So this is no, it fails the vertical line test. Okay. All right. So why do we need to know if something passes the vertical and horizontal line test? Because if it's one-to-one, then it can have an inverse. All right. So, inverse functions. The inverse of a function f of x is written as f inverse of x. F to the negative 1. Again, it's not f to the negative 1. It is the word inverse, because this is function notation with letters and whatnot. So we say f inverse of x. And it's important you understand not all functions have inverses. In order to have an inverse, it must pass the vertical line test and horizontal line test. It must be one-to-one. So it's a good thing to think about before we do all this hard work. Okay? So we want to look at this function and say, hey, is it one-to-one? And if it's one-to-one, then we can figure out the inverse. So here's how we're going to find the inverse. To find the inverse of a function, we switch the x and y. We swap the x and y and then solve for the new y. Okay? Swap and solve and replace our function notation. So that's what I like to say. So first of all, number 7, what shape is this graph? A line. It's a slanty line. Is it one-to-one? Yes, it is. It's 1-to-1 because it passes the vertical and horizontal line test, okay, because it's a slanty line. Now, in order to find the inverse, this says y equals 4x minus 8. We're going to swap the x and y. So I write x equals 4y minus 8. Swap your x and y. Are you good with that? Yeah. Okay. And then we're going to solve for y. We're really, really, really good at this. So if I'm going to get y by itself, what do I do first? Add 8. You get x plus 8 equals 4y, and then divide everything by 4. So we get x plus 8 all divided by 4 equals y. Now, I'm going to say it's not a y. We started with function notation. We want to end with function notation. So we use our inverse notation, f inverse of x, okay? Questions for me there? Okay. Number 8. So the first thing I need to ask myself is, yeah, the line test. Is it 1-to-1? What shape is it? It's this S-y shape. It's a stretchy S. It's sort of sideways like this. It's sort of the laying down curve like that. So yes, it's 1-to-1. So yes, we can find the inverse. So we're going to swap and solve. So not y equals, but instead x equals 1/2 y cubed minus 1. What should we do first? Add the 1. So I get x plus 1 equals 1/2 y cubed. I would love to times by 2. Yeah, we want to be a little careful. We got to multiply everything by 2. So the 2's go away. I'm left with y cubed equals, if I multiply everything by 2, what do I get? 2x plus 2. Very good. Multiplying everything by 2. 2x plus 2. And then cube root. Very good. To cancel the cube, we use a cube root on both sides. So the cube root and the cube cancel out, and we have the cube root of 2x plus 2, which we cannot simplify. Don't even bother trying. And I don't want to use y. What do I use instead of y? F inverse of x, because this is the inverse function. What's really interesting is you can look at them graphically to see if you did it right. So watch what happens when I graph the original and our inverse. So if I plug in my original, I have 1/2 x squared, cubed, just kidding, x cubed minus 1. And I'm going to graph my inverse, which math menu, there's my cube root of 2x plus 2. Now, if I graph both of these, that's, oh, I did it the wrong way. Just kidding. Look at that. They're kind of interesting. Oh, let me do this. I'm going to put one more thing in here. You're going to see this tomorrow, I think. The line y equals x. The line y equals x goes right through there. I'm going to do a zoom square so you can see this is a square graph. Why does it look so crappy? Is that better? No. What, is that worse? Why is it so awful looking? Is that better? Can you see me now? Looks terrible from here. Okay, anyway, so when you look at these two curves, the red and the blue curve, they're a reflection of one another. They turn out to be a reflection of each other across the line y equals x, which is exactly what we did when we swapped the x and the y. All right, all they're doing is trading places. And you can see how what happens, I'm going to look at the table, so second table. And when you look at these values, they are, let me find a good one here. It's hard to tell. Oh, you know what I can do? Let me do table settings. Let me show you. You can do this ask instead. All right. I'm going to do like a 1. If x is 1. All right. What if x is negative 0.5? No, that didn't work either. So there. On the blue curve, we have the ordered pair 1, negative 0.5. And then on the red curve, those ordered pairs swap. So on the red curve, it was negative 0.51. So you see how the ordered pairs swap, okay? Oh, maybe I could do it right on the graph. Let me do trace 2. All right, I have the nice, on the blue graph, I have the 0.23. So what point should I expect to see on the red graph? 3, 2. So I'm going to type in 3. And, 3 on the red graph. Ah! Sorry. I don't know why it just decided to do that, but that's okay. Let's go, let's go. All right. So I'm on the red curve now, and I'm typing in a 3, and oh, no, that's not the red curve. 3. There it is. There's the red curve, and we have the ordered pair 3, 2. Okay? So the ordered pairs just trade places, which is kind of nice. Number 9. What do you do if it's not a 1-to-1? So, like number 9. So, like number 9, what shape is this curve? A parabola, right? And so, is it 1-to-1? No, it fails the horizontal line test. So there is no inverse here. We cannot have the inverse of that particular function. Let's look at number 10. Do you know the shape of this graph? Yeah, very good. So it's the little upside down L's, so to speak, the inverse relation kind of graph like that. So it is 1-to-1, and so we can swap and solve, all right? So I'm going to replace my y with an x, and we have 5 over y minus 8. Ooh, this is a tricky one. How are we going to get y by itself? We're going to, yeah, so this is basically a proportion. So we're going to take this whole denominator and multiply it to the other side. That's going to be x times y minus 8 is equal to 1 times 5. It's essentially a proportion, so we can cross multiply to solve. What do you want to do next? Divide by x. I would love to divide by x. Sure, we can divide both sides by x. If we divide by x, that side on the left goes away. I'm left with my minus 8 equals 5 over x. And then what should we do? Add 8, sure. So I get 5 over x plus 8. The y is alone now. I'm going to change it to f inverse of x. So we get f inverse of x equals 5 over x plus 8. Which is interesting. All right, questions on this one? All right. Let's look at number 11. It's the swoop shape. Good. This one's a flipped upside down swoop. Does it? Is it 1-to-1? Yeah, it is 1-to-1. All right. So we can find the inverse. So I'm going to swap and solve. So I have x equals the opposite of the square root of y plus 2 minus 7. And then what should we do? Add 7. So get x plus 7 equals the negative square root of y plus 2. And then? Multiply. Yeah, well, we can multiply both sides by negative or divide both sides by negative. Maybe dividing is more sort of normal, say. I got to divide both things by a negative. That's going to give me negative x and a negative 7 equals the square root of y plus 2. Yeah, that's exactly right. To get rid of the radical, we got to square both sides. So the square root and the square cancel out. And I'm just going to leave this negative x minus 7 quantity squared. I don't know that you need to multiply that out. I don't think it's necessary. And then how do you get y by itself? Subtract the 2. And we can just tack it onto the end here. So negative x minus 7 quantity squared and then subtract the 2. And that's going to be my F inverse function, and that is probably fine. I don't know. I don't remember how much simplifying I had to do on delta math. I'll have to look. Number 12, what shape is that? It's a V upside down because of the negative. Yeah. Is it 1-to-1? No. No, it fails. Fails the horizontal line test, so there's no inverse here. All right, last one, number 13. I don't think I need, yeah, what is this one? This is a cube root. What does the cube root function look like? Yeah, this is the sideways one. I meant to do the other one the other way. But yeah, so this is the sideways sort of S1, stretch yes. So this is 1-to-1, so we can go ahead and swap and solve. So we get x equals the cube root of y minus 9 all divided by 4. What do you want to do first? Yeah, absolutely. So we can times both sides by 4, so that divide by 4 times by 4 goes away. So we get 4x equals the cube root of y minus 9. How do we get rid of a cube root? Cube it. Power of 3 on both sides. So the cube root and the cube cancel out, and we get 64x cubed. Very good, because 4 cubed. Yeah. All right, equals y minus 9, and then we need to add 9. So we get 64x cubed plus the 9 is f inverse of x. So I think I'll maybe talk about this one tomorrow, but I do want to point this out first. What is this thing here where it says x is greater than or equal to 0? What is it telling us? The domain. They're telling us the domain. So right off the bat, first of all, what shape is this curve? It's a parabola, but they're saying, hey, we're only going to look at it for x values greater than or equal to 0. So we're going to ignore everything to the left of 0. So now, since we're only paying attention to some of it, does it pass the vertical and horizontal line test? Yeah, it does. This is a 1-to-1 function now. You can change it to be a 1-to-1. Yeah, so you can modify your function to change it to be a 1-to-1, which is kind of interesting. And so now this can have an inverse. We just have to be a little bit careful. Now, I don't think I want to talk about this today, so I think I'll start with that tomorrow. I'm going to look at delta math, though, and see.